Hello, dear friends. Greetings of the day. And as you know that in this channel, that is Hospitality Education PPT, we have started a new topic on facility planning, and more precisely, we are developing the concept of project management and network analysis. Already we have covered the first lesson, which is already there in YouTube. You can follow it up if you are interested in that. And today we have decided that to take it further to discuss in depth about the next part of management and network analysis. So I welcome you all to this channel, which is your own channel, a classroom beyond your natural classroom. And the name of the channel once again is Hospitality Education PPT. Welcome you all to this session. Let us see our scope of study first. What are the things we are going to discuss? If you remember that in our last session, we have discussed about mainly the introductory part of the project management and network analysis. We have clearly developed the idea that what is called a project, then how to talk about the activities, the duration of time. We have also discussed about the successor and predecessor. We have identified that of each activity, and we have also discussed on the dependency of the activities on which who are depending on which activity, and we have learned some basic guidelines of developing the project network. Today we'll take it further as I have committed, and our scope of study will practice after learning the different guidelines of developing a project network. Depending on that, we'll try to develop our network. Then we are going to discuss about the steps involved in project management. Depending on that, we'll discuss about the activity time in detail, and also we'll also discuss about the calculation of activity time through different methods, and mainly that is known as the forward pass method and backward pass method. Then we are going to discuss about critical path in this particular lesson, and we'll give you the concept of how to determine the slack and float of the event. So this is our point of concern for the session, and let us begin. Firstly, how to develop the network. Now if you see that here we have given one table which has got three columns. One is activity, then predecessors, and the duration of the activity. Like here the list of activities, you can see the activity A has got no predecessors and it has got the duration of 3 days. Activity B, it has also got no predecessor, but it has 5 days of duration time. Whereas activity C has got two predecessors, that is A and B. That means C is depending on A and B, and 5 days is the duration. And similarly, activity D, the predecessor is A, 4 days duration. E, F and G, all these things are given out here. Now we'll try to draw the network depending on the guidelines we have discussed in our last session. Those who have missed the session, please, I'll suggest and advise that you first complete that lesson, then go through this lesson. Then it will be very easier for you. Firstly, if you see that this is one node, we call it a node, a start node, and from there we can see that two activities are starting, activity A and activity B, because they have no predecessors. So from here we are getting one activity which is named as A, and similarly we are getting another activity starting from node 1, that is B. Okay, and then activity A is ending at activity 2, node 2, and activity B is ending at node 3. Now let us see that C is starting once A and B is the predecessor. Now here you can see there the concurrent activities A and B, they are from this point node 1, it is starting A and starting B. They are not meeting anywhere. Then how the C will start? That means we need to have one dummy activity to connect A and B. Now in which direction it will be connected? Now let us see the next one, D. After C, the D will start from A. That means D will start from A. Clear? So what our activity will be next? The activity will be connected with a dummy activity, and this is known as dummy activity. And now we can see that D is starting from A, and C is starting from A and B. So A started from here, ended here. B started from node 1, ending at node 3. Now once both A and B are completed, then C will start. So C will start from here. So that's why A and B is connected with the dummy activity. Okay. And D is now starting from A, where A ended. From there, D is starting. So this is D. Now see the next activity, E, is starting, predecessor is C and D. So C and D is the predecessor, that means C is starting from node 4. You can see that C is starting from here, where C and D has converged. From there, C is starting, E is starting, that is C after the completion of C and D. And now F, the predecessor of F is A. A is that means it is starting from this point. So it is starting from this point after completion of A, this is F, and G is again starting, predecessor is A and B, that means A and B from here. So you can see that F, E and C, they are the end nodes, and here our project ends. So I repeat once again, I'll go back, just have a look how it is starting. It is our start node. A and B has got no predecessors. So A and B is starting from start node. C is starting, predecessor is A and B. That means A and B both will be completed. From there C can start. Now, but A and B from the figure we can see they are going in different directions. So they are not ending at one point. That is, as per the guideline of the project, they cannot complete at the same point from, or start from the same point. They have started, they cannot complete at the same time. So naturally they should be connected with a dummy activity. Now you can see the next one, D is starting from A. So D will be starting from A, C will be starting from after the completion of A and B. That means we need to connect these two, 2 and 3 node through a dummy activity. So that is D, and this is known as dummy activity. From there, now the C will start. You can see the C is starting from there. Now D is starting, Where the A is completed, that means A is the predecessor. So D is starting from there. Next, activity E is starting with the predecessor of C and D. That means C and D, once C and D will be completed, C and D will be completed, then only the E can start. So E will start from here. Correct? Now the F, the predecessor is A. That means it is starting from this. After completion of A, it is starting, that is F, and G is starting after completion of A and B. That means A and B is connected with the dummy activity. G is starting from there, and they are ending at one point, that is node 5. So this is your total network, and this is the way the network should be developed. If you are still having some gap of understanding, please put me in the comment box. We can discuss it further. So now we proceed to the next. Here we have written all the durations, like activity A has got 3 days time, activity B has got 5 days time. So all the activities in that way it is mentioned below the activity line. Activity lines are connected with the arrow that we have discussed. All the nodes are given a circle with a number. Number will be always from left to right. We have followed all the guidelines. Dummy activity always it should be given with a dotted arrow. So that is also mentioned out here. Clear? And it has got no time consumed, no material consumed. So that's why 0 days is the duration. Am I clear? And dummy activity is given for the to follow the guidelines of the project. Clear? Fine. Now, what are the steps involved in project management? There are basically 3 steps involved. One is the planning stage. Planning stage is nothing but it involves the setting the objectives of the project. First, you have to find out what are the objectives. If you remember, in our very first class, we have discussed about a boutique hotel, launching of the boutique hotel. So that was the objective. Now to do that, identifying various activities to be performed and determining the requirement of resources. And resources means man, machine and material, and of course money. The cost and time of the activities are to be estimated, and the network diagram is to be developed showing sequential interrelationships between predecessors and successors. So that is the first planning stage. Okay. After the planning is over, then it is the question of scheduling. What is scheduling? It is based on the time estimates. The start and the finish time of each activity are to be worked out. How it is to be done? By forward pass and backward pass method that we are going to discuss. Depending on that, critical path is identified along with the slack and float of the non-critical path. All these things we are going to discuss. We are in that stage now. We are in the scheduling stage now. And finally, the controlling, which refers to the plan, reallocation of resources, crashing and review of the projects with periodical reports are carried out. Crashing means what? Suppose a project is going to be completed by 15 days. Now, what will be your objective? Objective is that to, if possible, without hampering the quality and the quality of the project, that means completion of all the tasks, if you can reduce the project duration by at least 1 day, minimum for example, so what will happen? The project will be completed earlier, and that is known as a crashing down. That we are going to discuss in a later part of this series of discussions. Okay, so these are the 3 stages. First is the planning stage, second is scheduling stage, and final is the controlling stage. Okay, all these things will be discussed in coming series of lessons. Fine. Now we'll talk about activity time, because we are going to schedule, we are going to discuss about the scheduling. So activity time can be two times. One is the start time and the finish time. That means the activity will start and then it will be finished. So there is a start time and there is a finish time. But that is not all. There are more into it. Now there are basically two different kind of approaches. One is that suppose I have given you a task and I have told you that this task can be completed by 7 days. Fine. And the task is a simple, for example, a painting of a particular area. I have told you within 7 days you complete the task so that I can start another work on it, on this particular wall. Okay, your duty is to paint the wall and you are having maximum 7 days in your hand. Now you know, because of your experience, you know that to paint the wall, it will take only 4 days. So actual time will be 4 days. But how much you have given? 7 days. Fine. That means what you can do, you can start in two different ways. One is that 7 days, within 7 days the work has to be completed. You know that it will take only 4 days of your time to complete. So once you get a job, what you can do, you can start the work immediately on a 0 day and work continuously for 4 days and get the job over, and remaining 3 days you can rest and enjoy. Or else you can do one thing, you can start the work after 3 days, so that on 7th day, that means after completion of 4 days, you can complete the task. So on 7th day you can complete the task. These are two approaches. So you can either start early and complete it early, or you can start late and finish on the last day, the allotted day given to you. Clear? So these are two approaches. Depending on that, start time can be divided into two. One is earliest start time. That means if you are starting on the 0 day, there is the earliest start time, and depending on that, how much you are going to take. 4 days only. Depending on that, latest start time, you can start after 3 days, because you know within 7 days the work has to be over. So either you can start on a 0 day or you can start it on a third day, because you know the actual work will take 4 days only, whereas you have 7 days in your hand. Either you start on 0 day, finish it on 4th day, and 3 days you can relax, or you relax in the beginning 3 days and last 4 days you work. You got my point? So earliest you can start or latest you can start. Two times. Clear? Similarly, the finish time. If you start earliest start time, then earliest finish time will be there. Similarly, there will be latest finish. If you start late, there will be latest finish time. Clear? Fine. Now, how to going to be denoted? Earliest start time will be always denoted like E. Latest start time will be denoted with LST. Latest start time, just the acronym. Earliest finish time will be denoted by EFT, earliest finish time, and latest finish time will be denoted by L. Okay. Now we are going to learn about how to calculate the forward pass and backward pass method to find out the actual time. Now calculation of earliest start time, and which will be denoted with E by forward pass method. What is a forward pass method? I'll give you one situation out here. Suppose time provided to complete a task is 7 days, as I have mentioned. Actual time required to complete the task 3 days, that you know, that to paint the wall or to apply the primer or something, it will take only 3 days. That is the actual time, by experience, you know, because already you have done similar kind of job and that requires only 3 days. Okay. So how much relax or delay you can do? 7 minus 3, that is 4 days you can relax or delay the work. If this is the situation, now let us see the pictorial view. This is your start node, this is your end node, activity A, and your duration. How much it is given? 3 days. D12, duration is always denoted by D, and 12 is the starting node and ending node. 3 days. Either you can start on a 0 day. What is the actual time? 0 plus 3, that means total 3 days. So your earliest finish time is 3 days. You got my point? You have started on 0 days. 3 days is the actual time. So your earliest finish time is 3 days. You are moving forward. So earliest finish time is equivalent to the E for the next activity. Now remember that this earliest finish time is not the earliest finish time of a node, because node does not consume any resource any time. This is just the indication from where one activity is ending and other activity is beginning. So if A is finishing on 3rd day, so that is the earliest start time for the next task. You got my point? So that will be the denoted by E for the next activity. Okay? Is that clear? If you can complete the task on 3rd day, then only the next activity will start. Otherwise, it cannot start. So that 3rd day will be the early start day of for the next activity. That means if there is a second activity, that is B activity, activity can start on 3rd day only, not before that. So that is the earliest start time. They will finish and they will start. Activity A will finish and earliest finish time, and B can start on the 3rd day only. You got my point? It is known as a forward pass method. You take another one example. And here the situation is like this. Here you can see you got one activity A, another activity B, another activity C, all converging to one point, that is 4, node 4. It is in the middle of the activity. Okay, don't think that it is events are starting from here. It is somewhere in the event. And then the next activity D is starting from there. This is your situation. Okay. Now activity A duration is 4 days. Activity B duration is 5 days, and activity C duration is 6 days. Okay. Now let us consider that earliest start time or earliest finish time of the earlier activity is 2 in case of A. That means A can start on the 2nd day. It is the earliest finish time of the previous activity predecessor. Then only A can start. Similarly, the E, in case of B, the predecessor can finish it. Earliest finish time is 3. That means it is the earliest start time of B. And in case of C, here E is 4. That means it is the earliest finish time of the predecessor, and that is the earliest start time of C. Clear? So this is the situation given. Now you have to find out when D can start. Now to calculate by forward pass method, earliest finish time, we have to calculate the earliest finish time of A at this node point. So to calculate the earliest finish time, what is the formula? Earliest start time, that is 2 plus 4, 2 plus 4 is 6 for A. Then what is the earliest finish time of B? It is 3 plus 5, that is 8 for B. And then earliest finish time for C will be earliest start time 4 plus duration, that is 6, equal to 10. Now we got 3 activities are marching out here. Earliest finish time of A is 6, earliest finish time of B is 8, and earliest finish time of C is 10. Which one is to be taken? Out of these 3, consider the maximum out of these 3 earliest finish time at node 4. That is, and which one is maximum? 10. That means earliest finish time of D, earliest start time of D, that is E at that point, is 10. That means D can start the work on the 10th day, not before that. You can easily understand that A is completing on 6th day, B is completing on 8th day, C is completing it on 10th day. So you have to wait after 10th only you can start, not before that. So we are calculating the earliest finish time of all these 3 activities, 1 activity, 2 activity, or 3 activities, whatever they are coming to this point node 4, and calculate their earliest start time plus the duration, again the earliest start time plus duration, earliest start time plus duration. Once you get these 3, out of that you take the maximum, and that is the earliest start time for D from node 4. Clear? So this is the 2 different situations shown to you, and this is the way the forward pass calculation is to be done. Clear? Any questions I am telling you, please put me in the comment box so that I can help you out to understand it in a better way. So let us proceed. Now, calculation of latest finish time or backward pass method. What is that? Let us take again a situation. This is the situation where one activity is starting from node 1, going to be finished on node 2. Duration D12, 1, 2 is 4. And here it is mentioned that your latest finish time is given 7. That means activity A can finish the work latest by 7th day. Okay. So now backward pass. We will start from here. We will consider that, take the arrow. This arrow is from 1 to 2. Now let us imagine that arrow will be reverse from 2 to 1 because we are following the backward pass method. Now latest finish time is 7, duration is 4, then 7 minus 4 is what? Is the latest start time. Latest start time is 3. Okay? And it is known as L, equivalent to L of earlier activity. Latest finish time, or it is the latest finish time of the earlier activity, or it is known as the latest start time of the activity A. You got my point? So once you know the latest finish time at this point by 7th day, and you know the duration is 4, then 7 minus 4 backward is 3, and 3 is either we call it LST, that means latest start time of activity A or latest the finish time of the earlier activity. Got my point? This is situation 1, backward calculation. We are considering this arrow is reverse and we are considering L, that means latest finish time at this point minus duration is the latest start time, or L at this node. Clear? Now another situation will take. Suppose we are having one activity A, another activity B, another activity C. These three activities are starting bursting out from one node, that is A. That is 1. Okay. Now A duration is 5 days, B duration is 6 days, C duration is 7 days given. Now here, now what we should know? Now we will be concerned about the latest finish time. Latest finish time of A is 10, latest finish time of B is 8, and latest finish time of C is 11. We have to find out the latest start time at this point, node number 1. So what we are going to do, we'll go backward, we'll take all these arrows to the reverse direction. That means we'll start from here. So 10 minus 5. So latest start time of A, latest A, when A can start late by late, latest start time of A is 10 minus 5 equal to 5. Similarly, latest start time of B, 8 minus 6 equal to 2, and latest start time of C will be L minus 7. Latest finish time minus duration equal to 4. Now out of these three, which one will be considered? Consider the minimum value, which is the latest start time at node 1. That means the L of earlier activity. Okay. So that is LST, latest start time at node 1. You got my point? If you have any question, please ask me there in the comment box. So whenever you are going for a forward pass, come from, start with a node with the smaller number, go forward as per the direction of the arrow. If you are going for a backward pass, you always go backward, considering that you are going in the reverse direction. Okay, and this is the way. In one case, in a forward pass method, we do by get the time by adding it, and in case of backward pass method, we get the time by minusing it. Clear? Okay. Now let us take one ready-made network in front of us, that our network already we have developed in the beginning to start with this lesson, and here we can see that there are different activities. Activity A duration is 3, activity B duration is 5, activity C duration is 5 days. It is connected with the dummy activity, so no time is allotted. Activity F duration is 4, activity E duration is 4, activity G duration is 4. Now already we have learned forward pass method and backward pass method. Let us try to calculate the E on different point. So first is the forward pass method. Now let us start from 1. We can see that one arrow is going to this direction at node number 2. So what will be the E on this point, on this node? First let us consider starting point. The earliest start time, let us consider it is 0, because we are going for forward pass method. So naturally it will be 0. On 0 day you can start. Now the next one, From here we are starting the work, going to node number 2, activity A. Activity A duration, actual duration is 3, starting on 0 day. So what will be the value of E at node number 2? Value of E will be 0 plus 3, 0 plus 3, that is E, that is 3 at this node number 2. Similarly, from 1, we can see 2 activities are coming. Let us find out what will be the value of E at node number 3. Now you can see how many arrows are coming to that node. One arrow is here and another arrow is here, which is a dummy arrow. So let us find out 1 to 3, that is one path, and then 1, 2 and 3, there is a dummy arrow. So 1 to 2 already it is calculated, it is not coming out here, you have to consider this. So what is the thing we can take? First is 0 plus 5 equal to 5, and here 0 plus duration is, here the start point is 3, it is starting on 3rd day, duration is 0, so 3 plus 0 is 3. I'll repeat once again. From here this arrow is coming, so here the earliest start point is 0, duration is 5, so 0 plus 5 is 5, 1, and here earliest start time is 3, duration dummy activity is 0, so 3 plus 0 is 3. So out of 5 and 3, which one is to be taken? Maximum part will be taken. So here the value of E at node number 3 will be 5. Clear? Let us understand the next. Now take this point. Node number 4. How many arrows are coming out here? One arrow is coming from 2 to 4. Another arrow is coming from 3 to 4. So here the earliest start time is 3. Duration is 4. And here the earliest start time is 5 and duration is 5. So 5 plus 5. We can see, we can calculate 3 to 4 and 2 to 4. These are the two paths coming to this node number 4. So 3 to 4, earliest start time is 5 plus the duration, that is 5. So 5 plus 5 plus 10. And second one is 2 to 4, earliest start time is 3 and duration is 4. So at this point 3 plus 4, that means 7. So 10 and 7, these are the 2 points we have received, 2 duration we have received. Which one will be maximum out of these? Obviously 10. So here at node number 4, the value of E will be 10. Clear? Very easy calculation. Now let us see at node number 5. Now node number 5, how many arrows are coming out here? One arrow is coming from 2 to 5. One arrow is coming from 4 to 5 and another arrow is coming from 3 to 5. So you got 3 paths out here. So one is 3 to 5. In case of 3 to 5, here the earliest start time is 5 and duration is 4. Okay. So 5 plus 4 is 9. Now here 4 to 5, 4 to 5, earliest start time is 10, duration is 4. So 10 plus 4 is 14. And this arrow 2 to 5, where earliest start time is 3 and duration is 4. So it is altogether 3 plus 4 equal to 17. So 9, 14 and 14, out of these which one is maximum? That is 14 is the earliest start time of this. Okay. So 9, 14 and 7. These three, out of that maximum is 14. So E will be 14 at node number 5. So by using forward path method, we have calculated the E, that means earliest start time on every node. Clear? Now we'll apply the backward pass method. That means start from back, go to the front. Now you have to consider one thing first, that at this point where the earliest finish time is 14 for the entire project, that will be your latest finish time. These two will be the same, because once you know that if we start early to complete a project for and it will take only 14 days, then definitely if I start late also, but I cannot cross that 14 days. 14 days is the ultimate limit. Within 14 days the project has to be finished. So that will be our latest finish time. You got my point? If I tell you that this project will be completed by earliest by 14 days, so definitely it will be my latest finish time also. So these 2 points will be equal. That will be considered equal, same. So at this point I know the value of L, that is finish time. Now we'll apply the forward path method. Forward path method, first let us see at this point. Node number 4 will be applying backward pass method. Sorry. So how many arrows are coming back to this node number 4? Only one arrow. This arrow is initially coming from 4 to 5. Now we'll consider it 5 to 4. So 5 to 4, what will be the, we'll start with latest finish time, that is 14, minus duration 4. So what will be the value of L at this point? It will be 10. Okay. You got my point? Because single arrow is there. It is very simple to calculate. Now let us consider this point. How many arrows are coming back to this point? Let us consider this. Okay. At this node 3, 2 arrows are coming back. One arrow is coming from 5 to 3, 5 to 3, and another is coming from 4 to 3, 4 to 3. So what is the value of L at 5 and what is the duration? So 14 minus 4 is equal to 10, and here value of L at node 4 is 10. 10 minus 5 equal to 5. Out of these two, which one will be considered? The minimum of it. So minimum is 5. So here at this point, the value of L is 5. You got my point? Now let us consider these. Node number 2. What are the paths? One is take how many arrows are coming back to this point. So for 5, take all the things to the reverse direction. So 5 to 2 is one path, 4 to 2 is another path, and 3 to 2 is another path. These 3 points are coming back. So 5 to 2, here L is 14, duration is 4. So 14 minus 4 is 10. From 4 to T, here L is 10, duration is 4. So 10 minus 4 equal to 6 is 1. And here L is 5, dummy duration is 0. So 3 to 2 is 5 minus 0 equal to 5. Which one will be taken out of these 10, 6 and 5? Minimum is 5. So at this point the value of L is 5. Now remaining one is this, node number 1. How many arrows are coming back? 2 to 1 and 3 to 1. 2 to 1, L is 5, duration is 3. So 5 minus 3 is equal to 2. Sorry, it will be 2. It will be just a typographical mistake. It will be 2. Then at this point 3 to 1, value of L is 5, duration is 5. So 5 minus 5 is 0. So 2 and 0, which one is minimum? 0 will be taken into consideration. The value of L is 0 out here. So note that the earliest start time and latest start time will be 0 in both the cases. And in both the cases, earliest finish time of the project and latest finish time of the project will be the same. Clear? So this is a way we can apply the forward pass and backward pass method. If you have any questions on these, please ask me in the comment box. I'll be definitely clarify it again and again for you. Let us proceed to the next. Now we'll talk about critical path method or critical path analysis. What is that? This is a very important point. Remember, the critical path is in any network is the longest path through the entire network. It is the longest path to the entire network. That is the first point. Second thing, since all the activities must be completed to complete the entire project, the length of the critical path is also the shortest time allowable for completion of the project. That's why in an earlier example we have seen that earlier finish time and the latest finish time will be the same, and earlier start time and earlier latest finish start time for the entire network will be the same. That is the shortest time. Okay, fine. Thus, if the project has to be completed in shortest time, all the activities on the critical path must be started as soon as possible. So without wasting further time, you have to start the work on the critical path. What is the critical path? The longest path in the network. Okay, for the timing, you remember that. Now, earlier point, if you remember, thus if the project has to be completed in shortest time, all the activities on the critical path must be started as soon as possible, and these activities are called critical activities. In the longest path, the activities are there that has to be started then and there as early as possible, and that is known as the critical activity. If the project has to be completed ahead of the scheduled time, then the time required for at least one of the critical activity must be reduced. Now this is very critical point. Suppose your entire project duration is 14 days. Now if you want to reduce the project duration by at least 1 day, then what we are going to do? We have to reduce 1 day on the critical activity only. Because critical activity is such activity which is the longest that has to be completed to complete the project. So if you can compromise with 1 day over there, then your project duration will be reduced. Okay. Further, any delay on the critical activities will increase the project duration. Other way, if you are somehow delaying to complete the critical activities anywhere for some reason, then what will happen? your project duration will be increased because that is the longest path of the project. Clear? The activity does not lie on the critical path is called non-critical activity. So there will be two kind of activities which are falling in the longest route, that will be the critical activity, and that there is no relaxation time, you have to start immediately and finish immediately so that the next work can start. Other than that, the other activities, that is known as the non-critical activities, where the non-critical activities may have some slack time or relaxed time. You can relax. Like we have given you the example, we have given you 7 days of time and you have to complete the painting of the wall, and you know by experience that it will take 4 days maximum to complete the actual time required, but allotted time is 7 days. So what is the slack time? 3 days of slack time. 7 minus 4, 3 days. That means that path is not exactly a critical path, it is a non-critical path because there is a scope of relaxations. You can slack, you can slow down, you can wait, you can relax. The slack is the amount of time by which the start of an activity may be delayed without affecting the overall completion time of the project. So remember now, or try to understand that in a network, project network, there are different activities, all are sequentially connected. Out of these all possible activities, the most longest path, that is your critical path. Now critical path, there is no relaxations possible. You have to start immediately, complete it immediately. If you are delayed in the critical path, your project duration will be increased unnecessarily. Other than the critical path, the other non-critical path, there is some possibility of having some slack or relax without affecting the duration of the project, because that won't affect you in duration of the project. Okay. But a critical activity has no slack time. Critical activity has no slack time. To reduce the overall project time, it would require extra resources at extra cost to reduce the time taken by the critical activity to complete. Try to understand that there are certain paths which are critical. Now your purpose is to reduce the project duration at least by 1 day. And we have told you that to reduce the total project duration, you have to reduce the activity in the critical path, the duration of the critical path, one of the critical paths. Now what we can do, suppose our critical path is taking 3 days time, the normal resources and all, and if you want to crash down that or reduce that, you have to employ some extra resources over there, extra manpower over there, or extra machine over there, then only it will be reduced. So that is the most critical activity to complete. Now we'll teach you, we have discussed about the slack and float, now we'll discuss that. What is that? The float or slack of an event is the amount of time available by which it is possible to delay its completion time without extending the overall project completion time. There are two different kind of activities I told you. One is the critical, other one is a non-critical. Suppose in a critical activity, your duration is 3 days. You have to start on 0 day and finish on 3rd day. There is no relaxation or scope of slack. But non-critical activity, there is a scope of relaxation, which will never affect the completion of the project time without extending the project time. That is the float or slack. So float or slack of an event is the amount of time available by which it is possible to delay its completion time without extending the overall project completion time. You got my point? Take it further. We call it total float, which is indicated by S, denoted by S. What is the total float? Maximum relax or delay provided to any activity without affecting the project duration. Regarding the float, we know that the amount of delay available or possible. Total float is the maximum relax or delay provided to any activity without affecting the project duration. In an activity, it is the difference between the latest start time and earliest start time. So latest start time and earliest start time, that is the difference, that is known as the total float or relax. You got my point? Latest start time, maximum late, how many days we can start, and earliest start time, when we can finish and we can start. So one is the latest start time, lately when we can start, and earliest when we can start. So the difference between these two is known as the total float, L minus E. Clear? Now let us take up the example. So here the activity is ith, starting from ith node completing to jth node, activity A. Here the earliest start time at ith node is 5 and latest start time is 8 at the ith node. Similarly, what will be the value of S? The value of S will be the total float, difference between L and E, latest start time and earliest start time difference. So 8 minus 5 is equal to 3. Clear? Always calculate it by S equal to L minus E, as I have mentioned. Now, consideration. If the value is 0, the activity becomes critical activity. If the value is 0, the activity becomes critical activity. Remember this, because we will work on these further in the next session. If the value of above is more than 0, the activity becomes non-critical. So if the value of S, that means the total float is 0. Total float is calculated by latest start time minus earliest start time. If it is 0, the path activity becomes critical activity. If it is more than 0, it becomes non-critical activity. Clear? With this, we are at the end of the session. We have discussed many vital areas today, and thank you very much for attending this session with all your focus. If still you are having some doubts, don't forget me to put me in the comment box with your critical question. I'll get back to you with the right answer. And if you have liked the session, please press the like button, subscribe it, and also press the bell button so that you can get the alarm as early as whenever the next lesson will be completed. Now, till then, your comments are very, very important. Your feedback is very important. So please don't forget to give your comment, whether it is negative or positive, whatever. Until then, take care. Goodbye.